Okay, so this is a topic, it's called related rates. And basically what's happening is that several things are changing at a certain rate and you're trying to figure out how fast something else is changing. And so whenever we do these problems, you're going to have remember when we did implicit differentiation and you always had to have the y prime? Well, in this case, you're going to have y primes and x primes. You're going to have primes for everything that you do because everything is changing. So the first problem, it says air is being pumped into a spherical balloon at a rate of 20 inches cubed per minute. How fast is the radius of the balloon increasing when the radius is 6 inches? So you start off with the formula for whatever the problem is talking about. This problem is talking about a spherical balloon and air being pumped into it. So we need to know the volume of a spherical balloon. Now I will tell you, you don't have to memorize that formula. In a problem like that, they would give you the formula for the volume of a sphere. You do need to know like area of a rectangle, volume of a cube, Pythagorean theorem, those kinds of things. But they would give you the volume of a sphere. So I'm going to go ahead and tell you that the volume of a sphere is 4/3 pi r cubed. Alright, it tells me that the air is being pumped in at that rate. Well, that is how fast the volume is increasing. And I can tell because it says inches cubed per minute. Volume is in inches cubed. If it was the radius, it would just be inches per minute. So I know that V prime is 20 because that's the rate of change of volume. Alright, it says how fast is the radius changing? That means it wants to know R prime. It wants to know how fast the radius is changing. And then it also tells me that the radius is 6. So, you're going to start off with the problem. You don't do anything with those numbers at first. The first thing you do is you find the derivative of whatever the formula is. So the derivative of volume is volume prime. The derivative over here, R is our variable. We're going to multiply 3 times 4/3, leave our pi, and then we'll have R squared. And then we multiply that by R prime because everything is changing over a certain period of time. So everything is as a function of time, so there's primes everywhere. Alright, then I'm going to plug in what I know. I know that 20 is V prime. I know R is 6, so that's 36. And then I know that I'm looking for R prime. Alright, so then from there, you can multiply it if you want to, or you can divide it all out at the same time. Just make sure that you put all that bottom in parentheses if you do it in the calculator. You get 0.044, remember always to 3 decimal places. And then don't forget your units on these problems. It's about the radius, so it's inches per minute. If it were area, it would be inches squared per minute. Volume is inches cubed per minute. But radius, length, width is all inches per minute. Alright, number 2. We have a ladder leaning against a wall. We're going to call the ladder L. And I know that the length of the ladder is 25. The floor is slightly slippery and the foot of the ladder slips away from the wall at a rate of 0.2 feet per second. So the ladder is going that way. And I'm just going to call these A and B for now. It says it slips away from the wall at 0.2 feet per second. That's telling you that B prime is 0.2 because the B part of the wall or the length is changing at that rate. How fast is the top of the ladder sliding down the wall? It's asking about A because the ladder's coming down. So it's asking about A prime. And then it says when the top is 20 feet above the floor. So it's telling me that A is 20. Now, I need to come up with some kind of formula that relates A and B and L. And so the formula I can think of would be Pythagorean theorem. So we'll have A squared plus B squared equals L squared. Now, you're going to find derivatives. Everything is changing. The A is changing, the B is changing. The L is not changing, so that one's a little strange, but I'll show you that in just a second. Let's just go ahead and take the derivatives. Derivative of a squared would be 2a, and then you put your a prime with it. 2b, b prime with it. And then 2l, and l prime with it. Now, in order for me to solve this for a prime, I need to be able to fill in all of that information. I'm going to write this under number 3, knowing that that is not number 3, okay? Here's what I know. I know that L prime is 0 because the ladder is not changing. So the rate of change of the ladder is 0 because it's not changing. So all of that is really just going to equal 0 right there. Now, I need to be able to find B, because if you look at what I'm given, in order for me to find A prime, I've got to fill in all of my stuff. Well, I don't have what B is, so I need to find B. So separate from that, I'm going to do the Pythagorean theorem with the A, the B, and the L that I'm given. And I'm going to solve for what B is, because that's going to help me find my final answer. So I'd subtract the 20 squared and then take the square root. You're going to get 15 for B. Alright, so then once I know all of that, then I'm going to plug in everything into the blue up there. So I'm going to have 2 times 20 times A prime plus 2 times 15 times B prime equals 0. And then I solve. You can multiply all that and then subtract it over. So you're going to end up with A prime equals, go ahead and multiply 2 times 15 times 0.2. Subtract it, so it'll be negative. And then divide by 40, because 2 times 20 is 40. And you'll get negative 0.15. And go back to our units a minute. A prime is how fast it's going down the wall, so that's just 1 unit. Everything's in feet in minutes. So it looks like that this would be, oh, it's in seconds, I'm sorry. So that would be in feet per second. Now I want to tell you why A prime is negative. Notice that the length of the ladder above the floor, it's going down. So the rate had to be negative. That's the reason that it comes out to be negative when you work out the problem. Because it's going down the wall, so the length of that side is actually decreasing. We're going to skip number 3 and number 4 for a little bit. We'll come back to it. I want to go down to number 7 and then we'll go backwards. So here's another ladder problem. It's very similar to the other one, but I just wanted to do another one like it so that you could see how to do it. So again, we have a ladder, 6 meters leaning against the wall. The base of the ladder is sliding away from the wall at a rate of 1 meters per second. So if we do A and B again, then B prime is 0.1. How fast is the top of the ladder sliding down the wall? So we're looking for A prime again. When the base is 3 meters from the wall, so the base is 3. And we know the ladder's 6. So we do this problem very similarly. You're going to do A squared plus B squared equals L squared, or 6 squared. You're going to go ahead and figure out what A is. Then you're going to do the A squared plus B squared equals L squared. You're going to find the derivatives, and then you're going to solve for A prime. I'm going to leave this one to you since I went ahead and set it up, and that'll be one of your try problems. Alright, let's go back to number 5. Ship A is 32 miles north of ship B. So if B is here, A is way up here. It's sailing due south at 16 miles per hour. So here is like where it is. It's 32 miles. It's sailing due south, so it's going down at 16 miles per hour. Okay. Now, I'm probably going to label that. Maybe I want to label it as A, and that tells me that A prime is negative 16 because it's going south, and that 32 would be getting smaller. Okay, ship B is sailing due east, which means it's going this way, and we'll call that little b, and it's at 12 miles per hour. See, the A prime and the B prime, they're still rates, and when you talk about how fast that they're going, that still represents its rate. That's why it's in miles per hour. At what rate is the distance between them changing at the end of an hour? So it says the distance between them. Here's the distance between them. Maybe that's C. It's asking what C prime is. And it says at the end of an hour. So I already know that A is 32 because that's how far it is north of ship B. And what it's asking me is at the end of an hour, how fast it would be changing. So what I can do is I can figure out B and C based on that. Since it says at the end of an hour, and I know that B is traveling at 12 miles per hour, well, that tells me that the B part would be 12. So the length of that B will be 12 because it's going at 12 miles per hour. To find C, again, I'm going to do Pythagorean theorem. I'm going to do, I realize that on A, it's really not 32. It does tell me it's 32, but because it says at the end of an hour, where is it? Then I have to do like I did on the B. The A was traveling at 16 miles per hour. It was at 32. Now it's at 16 less, so A is still 16. Sorry about that. Now to find the C, I do Pythagorean theorem. 12 squared plus 16 squared equals B squared or C squared, and I find out that C will be 20. So now I'm just going to do A squared plus B squared equals C squared. I'm going to find the derivatives. Plug in everything I know. And then I'm going to work that out. So I'm going to multiply and I'm going to get 2 times 16 times negative 16 plus 2 times 12 times 12. You get negative 224. Then you divide it by 40 to get C prime by itself. And so I get negative 5.6 equals C prime. C prime is how fast the distance is increasing or decreasing. And it's in miles per hour, so this is miles per hour. The negative just means that the distance between A and B is actually decreasing. Okay, let's skip on down to number 8. It's a little bit easier than the triangle ones. When a pebble is tossed into a still pond, ripples move out from a point where the stone hits in the form of concentric circles. Find the rate at which the area of the disturbed water is increasing when the radius is increasing at a rate of 2 meters per second. So we're talking about something that's circles and how the circles get bigger. So the area is getting bigger, the radius is getting bigger. The area is what we're looking for, so we're looking for like area prime. It tells us the radius is increasing at the rate of 2, so that's radius prime. Every time I do that R, I'm representing radius, not rate. And so I need a formula that relates area and radius together, which it's a circle. This is one you would need to know. That's area equals pi r squared. So let's find the derivative. Area prime equals 2 pi r prime. Substitute in what we know, which is only r prime. although there's no more information to plug in, that means that the area prime, this is the rate that it was increasing, depends on what R is at that time. You could then plug in the R if it gave it to you, but it didn't. And then you write your units. This is talking about area, so that would be meters squared per second, since the radius is meters per second. Sorry I keep skipping around, but I want to make sure that I get to all the different kinds, and I want to make sure the hardest are saved for last if possible. So number 4, let's look at that one. On a dark night, a thin man, 6 feet tall, walks away from a lamppost 24 feet high at a rate of 5 meters per second. So here's the lamppost. It's 24 feet high. Here's the man. He's walking away from the lamppost going that way. And he's going at a rate of 5 meters per second. And he came from the lamppost. I'm going to call this X here. So that means that X prime is 5. How fast is his shadow lengthening? Alright, this over here is where his shadow would be. If you think about the lamp and it's shining down that way, we'll call that S. So shadow prime, or S prime, is what we're looking for. Now, these two triangles are similar triangles, so we're going to make a relationship with the two triangles. Alright, the big triangle, the bottom is X plus S, and the side is 24. And then on the right triangle, the one on the far right, this one here, the bottom is S and the side is 6. So let's just cross multiply and work that out, see what you get. You're going to get 6S plus 6S equals 24S. I multiplied 6 by that and 24 by that. Alright, still simplify a little bit more. Move that 6 to the other side, so 6x equals 18s. Alright, find the derivative. We have 6x prime equals 18s prime. Plug in what you know. And then look for s prime. So s prime is going to be 30 over 18, or 1.667. That's the length of the shadow, how it's increasing. So because it's just the shadow and not an area or volume, it's still miles per hour and not miles per hour squared, or miles squared per hour. It's a strange kind of problem. We actually didn't need the 24 and the 6 except whenever you cross multiplied. And the only hard part maybe on that one is to remember how to set up that triangle. Alright, so it looks like what we have left are the cone problems, which are 3 and 9, and then a problem relating an angle, which is 6. So I think that I will leave all 3 of those, and we will look at those later. I know that these are not the easiest kinds of problems to understand, so that'll give you some time to really think about them and make sure that you sort of understand them, and then we'll go over some more later.